Hi everyone, this is the second video for section 6.2 on adding and subtracting fractions. Okay, so now we want to talk about the properties of fractions and how to deal with fractions in mental math. So fractions are made using real numbers, right? So when we talked about in section 6.1 at the very beginning, what fractions look like, we listed all these different examples of what a fraction could look like. But one thing that the fractions we looked at had in common is that they all use real numbers. I looked at as one real number over another real number separated by this fraction bar. So because fractions are made using real numbers, any property that holds for addition and subtraction of the real numbers will also hold for fractions. And that's really nice because we've already talked a lot about the different properties for addition of fraction or addition of real numbers, and those follow for addition of fractions. And we've already mentioned these a little bit in the last video that right, we reassociated and used commutative properties of addition to work with fractions. So we're just going to make that a little bit more formal now. So remember that the commutative property is this property here, where a plus b equals b plus a, so it doesn't matter which order you add things in. And this similarly works with fractions. So if we have our fraction d over e, we're adding it to f over g. It doesn't matter which one comes first. It's the same. And similarly, the associative property says that we can reassociate. So again, if we're adding three things, it doesn't matter which order we add things in. It's still the same. And if we put those to look like a fraction, it doesn't matter here. I'm sorry about these parentheses being a little bit off. Okay, so if we look like fractions, it doesn't matter. If we're adding three fractions, it doesn't matter if we add the first two fractions first or the second two fractions first. It doesn't matter. Okay, so that's just kind of a refresher on these properties. I know I still say them and expect you to remember what I'm talking about, but just in case you've forgotten, here they are. Here they are, written formally again. Okay, so similarly, also, because the fractions in this chapter are typically only written with whole numbers, right? Whole numbers being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. A lot of the strategies we use for mental math could also be used here, mental math from chapter 4. So since we're dealing with fractions, summing to a whole number would be useful for using mental math here, because it's a lot easier to add up whole numbers than fractions. So I just want to show an example of how that works. So if we're adding this very long string of fractions, we want to use mental math to kind of define the sum. And I'm going to write out a little bit of work here. And if we're using mental math, remember we typically wouldn't write out a lot of work. But I'm just going to write it out here to kind of show you the thought process that you would have if you're doing this mentally. So we want to use this long string of fractions, and adding it just straight across is kind of difficult. So we want to use these two properties we talked about, the commutative property and the associative property, to kind of reorder what we're doing here. So one thing that I noticed is this 40 over 30 can add up pretty nicely with this 20 over 30. So I'm going to rewrite this as 40 over 30 plus 20 over 30. Okay, what else goes nice? 9 adds up nicely with 21. So I'm going to add up 9 over 30 plus 21 over 30. Okay, 13 goes nice with 17. So I'm going to add 17 over 30 and 13 over 30. And lastly, 37 and 23 go nicely together. So you didn't have to pick this order that I did. I kind of picked them so that the ones place would add up to a multiple of 10, which is how I kind of picked it. Oh, that's over 30. Yeah, so I just picked it so that the ones place would add it to 10, right? 9 and 1 adds to 10, 3 and 7 add to 10, 0 and 0 add to 0, so that it kind of made a nice number. So 40 and 20 add up to 60. So this is 60 over 30. 9 and 21 add up to 30. 17 and 13 also add up to 30. And 37 and 23 add up to 60. So we picked these numbers, we associated them nicely. So this is really adding 2 plus 1 plus 1 plus 2. And when we add this all up, we get 6. So definitely using mental math to kind of rearrange these things, or I mean, even just rearranging things in general makes this really nice, because we wouldn't guess that adding up this long list of fractions would just give us the whole number 6. But if we're using mental math to, if you're specifically instructed to use mental math to find a sum or a difference of fractions, it's typically just going to be something that works out really nicely like this. Otherwise, you wouldn't be used to ask mental math to do it. Okay, so the last thing is models. So there's a lot of different examples of models in the book. I mean, it's a little bit harder to kind of represent that in this video format, but models are helpful because it helps students gain confidence that we need to kind of really understand something. So I think models help students kind of visualize things tangibly, and just feel more comfortable doing things like this, especially when they see fractions for the first time. Fractions are a really big hurdle for a lot of students, and I mean, even a lot of adults can still struggle with fractions and kind of conceptualizing it. So models are something that can really help, add confidence and just kind of help people know that they're doing things correctly. So the book has a lot of different pictorial examples of models. We're also going to look at some of the apps that I have on here. But we're going to do that in another video. So I recommend looking at the textbook to look at the different types of models, but then also watching the next video.